Continuing with our discussion of exponential functions, we're going to look now at this example here. G of x equals 1/2 to the power of x. Notice the base is 1/2, and that is a constant, and the variable is the exponent, is in the exponent. So this is an exponential function. One way we could write this exponential function is we could write it, because 1/2 is 2 to the negative 1 power, and if I'm raising that to x, this is 2 to the minus x. So this is actually going to have the exact same shape as the function that we just looked at in the previous video, except it's going to be reflected across the y-axis, and that's because of that negative there. So when you put in negative values for x, because you're taking the reciprocal, you're going to, because of this negative here, you're actually going to get very small values, very close to the x-axis. And when you're on the negative side, you're taking the negative of your input, which is positive, and so those values are going to be large, like 8, 4, and 2 here. These are exponential values, and so it increases very rapidly. And just as with all exponential functions, their graphs pass through the point 0, 1, and the graph approaches but never touches the positive portion of the x-axis. So right over here, it's getting closer and closer to that positive side of the x-axis, but it will never touch. Notice that this function is decreasing as compared to the function 2 to the x, which was increasing. They both have the same shape, but because this one is a reflection across the y-axis of the previous example, 2 to the x, you'll get the same shape, but one was increasing and the other one is decreasing. And again, it's decreasing because of that negative exponent there. So the domain, as is with all exponential functions, is all real numbers, minus infinity to infinity, if we're writing it in interval notation. And the range is from 0 to infinity, not including 0. So exponential functions always have y as positive output, as long as you're not multiplying by a negative in front. But if you're just taking a positive base and raising it to a variable exponent, you're going to get a positive output. So the range then is from 0 to infinity, or all numbers greater than 0. Now this is an interesting thing here, pi. Remember the number pi? It's special because it is the circumference. You can take the circumference of a circle, divide it by its diameter, and you will get a constant for every circle. It doesn't matter what size the circle is. And because it's special like that, we give it a name, and the symbol in this case is pi. Well, e is something similar to that. Here, if we look at this expression, 1 plus 1 over n to the nth power, and we plug in, starting with 1 and getting larger and larger, we plug in values. So here we plug in 1, our output is going to be 2. If we plug in n equals 2, our output is 2.25. And even if we plug in 1,000,000, and this is actually 1,000,000 here, and this is 1,000,000,000, we're going to get closer and closer and closer to a constant, which is about 2.7. And that is an exact real number, and because it's lengthy and it goes on forever, we call it e. It's much easier to give it a name, just like we do with pi. Pi and e are irrational numbers. And so we work a lot with this number. Now, e is a constant, so it can be the base of an exponential function, and it often is in real life problems.